Hi everyone, I'm Shubhankar from Qualcomm AI Research, and today I'll present our CVPR 2026 paper, Ar2Can, an architect and an artist leveraging a canvas for multi-human generation. This work focuses on generating personalized images of multiple people together in a scene. Let's start with the problem. We want to generate images of multiple specific people together given their reference images. This is a very challenging task because the generated images must be photorealistic, identity preserving, and aligned with the prompt. However, current models struggle to do all three simultaneously, especially when the number of people increases. Our key idea is to break down this difficult problem into two simpler stages. We introduce two modules, an architect and an artist. The architect first generates a spatial layout of the scene, then the artist uses this layout as guidance to generate the final image. We train the artist using reinforcement learning, specifically GRPO. So instead of directly generating a complex multi-human image, we explicitly model where people should be first and then generate how they look. Let's move to the proposed method. Looking at the architect, our first variant, architect A, is an efficient model. It is an autoregressive language model trained to predict spatial layouts from text prompts. It outputs structured layout tokens that represents the position of people, and it gives us explicit control over placement. We also explore another variant, architect B, which is a fast diffusion model, and we fine-tune it with reinforcement learning to generate images with the correct layouts. Then we extract face positions from these images, so architect B learns layout implicitly through generation. There is a trade-off between both the architects, which we have explored in our paper. Let's move to the artist. The artist is the main image generator. It takes the prompt and the reference identities from a canvas. We train it using a reward that includes count accuracy, image quality, which is the HPS, pose correction, and more importantly, the face matching reward. We also sample groups of trajectories and update the model using GRPO, enabling stable optimization. A key component here is our face matching reward. We explicitly ensure that generated faces match the input reference identities. We do this by first performing Hungarian assignment to match input face centroids from the canvas onto the generated image. Then we apply a cosine similarity term on the arc face embeddings of each detected face in the generated image. This reward is critical for personalization and helps us avoid identity drift while maintaining the relative spatial arrangement of faces. We also introduce a canvas-based optimization for efficiency. The idea is simple. We dropped empty tokens of the canvas and reuse tokens for overlapping areas. This reduces computation by nearly half. At the same time, we enable shared positional encodings, which allow the model to account for natural occlusions and correct the depth ordering between people. So we can get both efficiency and realistic composition. Moving to the experiments, we evaluate on multi-human test bench dataset, which was established in NeurIPS 2025 datasets and benchmark. This includes up to 5 people and diverse scenes. We measure identity similarity, count accuracy, image quality, and action alignment. Quantitatively, Ar2Can can achieve the best overall performance across all the metrics. Strong identity preservation and high quality, along with prompt alignment. Interestingly, proprietary methods perform well on action generation from the text prompt, but struggle with consistent identity preservation. Qualitatively, the improvements are also pretty clear. Ar2Can can correctly place people, preserve identities, and generate coherent group scenes. Even more interesting, although we train primarily for human faces, the model can generalize to multi-object plus multi-human generation. This shows strong compositional capability from our proposed approach. To conclude, we presented Ar2Can, which is a framework that decomposes multi-human generation into layout and then rendering, and uses the architect-artist modeling, which leverages reinforcement learning for both these stages. This enables accurate spatial composition, strong identity preservation, and high quality image generation. Thank you so much for seeing our presentation.